Hello, we're looking at example 12, still on page 19, dealing with another geometric sequence question. In a geometric sequence, U1 equals 5. Okay, so that's going to be an important piece of information. And U5 is 1,280. The last term is 20,480. Given that R is positive, that's going to be another important piece of information. Find the number of terms in the sequence. Number of terms. Okay, so basically, we need to be able to find out what is n equal to when un is that last term, 20,480. And last term tells us that it's a finite geometric sequence. All right, so let's start off with, we know our general term for a geometric sequence is un equals u1 multiplied by r to the power of n minus 1. Okay, we know u1 is 5, so we can fill that in. And we also know at u5, we have this number 1,280. So let's look at u5, because at u5, n will be 5. That has to do with this 5 right here. N. Okay, but u5 we know is 1,280. So now this is r to the 4. All right, just solve normal algebra. We're going to divide both sides by 5. All right, and when we do that, what do we get? 10, 5, 3, 6. We get 256 over here, and we get r to the 4 over here. Now we can take the fourth root of both sides, which over here with r to the 4, that could give us plus or minus r, but in the question they told us that r is positive. Okay, so we know that r is positive. You might even want to write that here. R is positive given in question. So we're going to leave that positive. Take the fourth root of 256. So I've got a calculator. The fourth root of 256 is 4. All right, so r is 4. So now we know the general term un is equal to u1, which was 5, r, which was 4 to the power of n minus 1. All right, what do we need to do now? We know the last term is 20,480. The last term, we need to figure out what is n at that point. So let's substitute this in here. 20,480 equals 5 times 4 to the power of n minus 1. And we're going to solve for n. We can do that. There's only one unknown here. Okay. Divide both sides by 5. Okay, when we divide that by 5, that'd be 4, 0, 9, 6. Okay, I'll just double check that in the calculator. 20,480 divided by 5, 4096 to the power of 4, or equals 4 to the power of n minus 1. All right, let's remember our logarithms because we need to solve for this exponent. So remembering logarithms, we can either log both sides of the equation, log base 10, or we can rearrange into an exponent statement, which is what I'm going to do. Into a log statement, sorry. It's now in an exponent statement. So log base 4 of 4,096 is equal to n minus 1. So therefore, n is going to be 1 plus that number, log base 4 of 4,096. All right, remember if You're using a calculator that doesn't allow you to put the base in. You can use the change of base if you want, change of base rule. So we could say n equals 1 plus log base 10 of 4096 divided by log base 10 of 4. Let's calculate that number. Log 4,000, mine's showing base, so I'll do that. Base 4 of 4096 equals 6. Oh, nice neat number. So 1 plus 6, so n is equal to 7. So the question was, find the number of terms in the sequence. Therefore, there are 7 terms in the sequence. Now remember, n needs to always work out to be a positive integer because n represents the placement, the position in the sequence. There we go.